Hi guys, I just wanted to record this video really quickly to help show the standard algorithm since it is seen in 3 lessons that we work on together. So the standard algorithm is used in multiplication. You will have many algorithms as you move through math, but that really just means how we multiply two numbers. And the numbers 0 through 9, you don't need to use the standard algorithm for because those are your multiplication tables and you should have those memorized. Most people memorize through their 12s at least, so we can use the standard algorithm on any number that has 2 digits in it or more. So let's look at 12 times 7. We already know the answer to this problem is 84 if you have those multiplication tables memorized, but let's look at this. Let's use the algorithm to break this one down. That way we can check our work. So the standard algorithm says first you line up your numbers by place value. So my 2 is in the ones place, my 7 is in the ones place. I don't have a tens place that comes with the 7, but my 1 is in the tens place. So all my digits are lined up. And just like with addition and subtraction, I'm going to start on the right side of the problem and move to the left. So I'm going to use that property, our distributive property, and distribute the 7 to the 2 and to the 1, which is really a 10 because it's in the tens place. Okay, so let's do that. 7 times 2, that's going to be 14. But I'm not done multiplying, so I can't just write my 1 down here, so I'm going to carry it in the top, just like you would in an addition problem. Okay, I still need to distribute that 7 to the 1. I'm not done with this problem, so let's do that as well. 7 times 1 is 7. And then up here, I still have this little 1 left, and it actually gets added. So I'm going to write a plus 1. So 7 times 1 is 7, plus 1 is 8. Final answer, 84. And I'm just going to circle the final answer just so we know we're done with that problem. So let's try it on a 3-digit number. What about 180 times 5? Again, lining up our place values, 5's in the ones place, so it goes right under the 0 in the 180 because that also falls in the ones place. And this is just going to help you organize your math. It really helps out. So let's go ahead and multiply. I'm going to switch our pen color back here. So we're going to start on that right side. 5 times 0 is 0. I have nothing to carry, so nothing extra gets added on. Then I have to distribute again. 5 times 8, really, if you're thinking about those arrays we did, it's actually 5 times 80. So 5 times 8 gives me 40. The 0 I'm going to keep down here, and I still have a number to multiply, so I have to carry that 4. Last one here, 5 times 1. And remember, don't forget to add 4. So 5 times 1 is 5, plus 4 is 9. So my final answer is 900. So 180 times 5 is 900. And you can do this no matter how many digits you have in a number. 2.6 is using those double digits times a single digit. So tens place times ones place numbers. In 2.7, you're going to see double digits times double digits, which gets a little trickier because we have to use those placeholders when we're using this algorithm. So let's look at what that might look like. So let's take our 12 again, and let's multiply it by 12. Because if you have your multiplication tables memorized through your 12s, you should know the answer to this is 144. Okay, so we already know the answer, but I have to show my work. In the standard algorithm, it wants me to show how I got there. So I have to distribute. I'm just going to start on the right side of the problem like you always do. And this is where the tricky part comes in. So I'm going to use a completely different color that I haven't used yet. So 2 times 2 is going to be 4. Okay, I'm not done yet with this number. I'm going to keep orange for this number, this ones place. Then 2 times 1 is 2. 24. Well, I know I'm not done with the problem because 12 times 12 is a lot bigger than 24. 12 plus 12 is 24. But I've only multiplied one number. So I'm done with that too. You can leave it in the back of your mind, but I still have to get that 1 in the bottom left, in the bottom tens place. So that 1 is actually a 10, and because of that, I'm going to have to keep a placeholder. So this, I'm done with my ones place. Done with it. So I'm going to put a 0 there. No more numbers are going to go in that ones place because I'm moving on to my tens place. So 1 times 2, it's going to give me 2. And 1 times 1 is going to give me 1. Okay, so I've multiplied all the numbers. Now what I have to do is I add them together. So I add these two products together. So 4 plus 0 is 4, 2 plus 2 is 4, and 1 plus nothing is 1. 144 is my final answer. I know it's a little tricky. Let's look at some different numbers that we don't already know the answer to. What about 36 times 41? The cool thing about multiplication is, like we learned before with our properties, order doesn't matter when it comes to multiplying. So I can multiply my big number times my small number times my big number. In subtraction, you do have to pay attention to what order you're subtracting numbers in, but in multiplication, since it is commutative, it doesn't matter, which is nice. We can use some tricks for that later on. So I'm going to go ahead and switch my pen color here. We're going to start on the right side of our problem, and we're going to distribute that 41 to our 36, starting with our 1 in the ones place. So 1 times 6 is going to give me 6. And 1 times 3 is going to give me 3. Pretty simple. You probably could have looked at that, and if you had erased the 4, you would have seen that it's just 36 times 1. It's going to give you 36. Makes sense. But now, remember, okay, I'm done with that ones place, so since I'm finished with it, got to put my little placeholder 0 here. So now I have 4, or 4D technically, that's where that 0 is coming from. It's holding that ones place in the 4D. 4 times 6 is 24. So since I'm not done multiplying yet, I have to carry that too. So I'm going to carry it over here. Remember, that gets added. So I did my 4 times 6 was 24, carry my 2. 4 times 3 is 12, and don't forget, I'm done multiplying on that top row now, so I have to add that too. So 4 times 3 is 12, plus 2 is 14. So I have to write both of those digits down here now. Now that I'm finished, I get to add, because I've multiplied all the numbers in the second row. So we have 6 plus 0 is 6, 3 plus 4 is 7, 4 plus nothing is 4, 1 plus nothing is 1. 1476 is our final answer. And if you like commas, remember commas go every 3 numbers. Not 100% required. Just makes it easier to read numbers sometimes when you see those commas in there. Let's try one more, and then I'll be quiet. So here we have, let's try 10,700 times 400. I know, I just jumped huge numbers on you. Remember, we're still lining up our place values. I have up to my hundreds place in my second number here. So the factor on top, it's going to match up. My zeros are lined up. Perfect. I'm going to start on the right side. But when you start thinking about this, look at this problem. You're going to have to multiply zeros all the way across, zeros all the way across, and then 4 all the way across. do we really need to waste the time, because this is what it's going to look like. Do we really need to waste the time to say, okay, 0 times 0 is 0, 0 times 0 is 0, 0 times 7 is 0, 0 times 0 is 0, 0 times 1 is 0. And then we have to do that again, but we have to include this placeholder. So, okay, now we're on to that second 0. So here's a placeholder. And now 0 times 0 is 0, 0 times 0 is 0, 0 times 7 is 0, and so on and so on. And finally, I'm at my 4. So now I can actually do some multiplying here. But remember, I'm in the hundreds place, so I actually need 2 placeholders because I'm done with the tens and the ones place. 4 times 0 is 0, 4 times 0 is 0, 4 times 7 is 28. Carry that 2. 4 times 0, remember that gets added. 4 times 0 is 0, plus 2 is 2. And then last but not least, 4 times 1 is 4. Then I have to add all these. Does this seem pretty redundant though? I have all these zeros and I really don't need them. Because my answer, regardless of these zeros or these zeros, is still going to be this. Okay? Because when I add these, that's 0, that's 0, that's 0, that's 0, that's 8, that's 2, and that's 4. So 4,280,000. So, what 2.8 is about, it's showing us a trick here. At least one part of 2.8. 2.8 is showing us, let me reset this here. When you have two numbers that are multiplied together and they end in zeros, especially that second number, when you're looking at that second number and it's ending in lots of zeros, instead of multiplying all the zeros, we can just keep those as placeholders. Okay, I know these zeros are just going to work out as zeros, so there's one placeholder for my ones place. I know this other 0 is going to work out as all zeros when I multiply it across. Don't waste my time. Okay, there's another 0. Now I can actually do my multiplying because I'm to a number now that is not 0. So 4 times 0, 0. 4 times 0, 0. 4 times 7, 28. So I'm going to write my 8 because it's in the ones place, carry my 2. Remember that gets added. Okay, 4 times 0, 0 plus 2 is 2. 4 times 1 is 4. And I still got the same answer, but I did it a whole lot faster because I didn't have to write all those zeros. So 2.8, little trickier. It will take some getting used to, but keeping those placeholders is going to help us because you don't need to waste your time writing all of those zeros out when you could just get straight to the answer. Just like with an array, we saw this when we did those arrays, that when you had those zeros, you didn't need to make boxes for them, which was really nice. This is the same principle. You don't need to make lines that you're going to eventually add together because 0 plus anything is itself. That's our identity property of addition. So all our properties are coming together here, and I hope this helps. Sorry if it was a little lengthy. Let me know if you want more videos like this.